What is the link between Helmholtz free energy and maximum work? Imagine you have a sealed container filled with gas. You want to know how much work you can get out of it without changing its temperature or volume. That's where Helmholtz free energy comes into play. It's a special number that tells us the most work a system can give us when conditions stay the same. The Helmholtz free energy is calculated by taking the system's internal energy and subtracting the product of temperature and entropy. Think of internal energy as the total energy inside the system. Entropy measures how disorganized or spread out that energy is. When you subtract the entropy term, you find out how much energy is actually available to do useful work. This concept is especially useful when the system is at a constant temperature and volume. Under these conditions, the system cannot do work by changing its size or shape. Instead, the work comes from energy transfers like heat flow or particle movement. The change in Helmholtz free energy during a process tells us how much work we can get out of the system. If the free energy decreases, it means the system can do that much work before reaching a more stable state. When a process happens spontaneously, the Helmholtz free energy decreases. This decrease shows the system is releasing energy that can be used for work. The bigger the drop in free energy, the more work you can extract. But once the system reaches equilibrium, the Helmholtz free energy stops changing and hits its lowest point. That's when no more work can be gained because the system is in its most stable form. The connection between Helmholtz free energy and maximum work is clear. The negative change in free energy equals the maximum amount of work you can get from the system at constant temperature and volume. It's like a limit on how much energy you can turn into useful work before the system settles down. This idea helps scientists and engineers predict what's possible in chemical reactions, physical processes, or even designing engines that work efficiently. In simple terms, Helmholtz free energy acts as a measure of the energy left over after accounting for disorder. It tells us exactly how much work we can squeeze out of a system without changing its temperature or volume. When the free energy drops, it's a sign that the system is giving us the maximum work it can offer under those specific conditions. And that's how thermodynamics connects energy, disorder, and the work we can harness from nature's processes.